Let's talk about some basic terms of metabolism. These are all basic terms, they're simple terms. Don't be confused by them. They're so easy. Their name in almost every case tells you what they are. That's the great thing about them. They're big words. Don't be upset because there are lots of letters. They have several syllables. Don't be upset by polysyllabism, or would it be polysyllabism? If it's polysyllabism, that's great, because if you say it fast, it sounds like polysyllabism. Don't be afraid. Big words, lots of syllables, don't freak out. Let's take a look here. 6 terms I want you to know. Notice in every case we have lysis, genesis, lysis, genesis, lysis, genesis. Oh, yes. So let's take a look. Glycolysis, glycolysis. Remember what that suffix, that root means? It means break down. Like me, they call me, when I'm a professor, they call me Professor Enzyme, because I'm always breaking it down. I don't know what that means. That was terrible. I'm not even sure what I'm talking about. Now, I think I am now. Glycolysis, glycolysis. Glyco is a root word that sometimes means just sugar, like glycosuria. Sometimes it can mean glycogen as well. Here we mean just sugar. Glycolysis. We're going to break down sugar. Break down, what do you mean? Remember, sugar is a molecule, all right? Glucose is a complex molecule, C6H12O6, that actually has the energy of the sun stored in it. What we're going to do is we're going to break that down to release that energy to make it available for our metabolism. So in glycolysis, we take a molecule of glucose, and we turn that into 2 pyruvates. And from there, 2 pyruvates, we go into 2 ATP. All right? We use glucose to make ATP. That's glycolysis. Now, pyruvate can be plugged into the citric acid cycle, anaerobic respiration, oxidative phosphorylation. We can end up with 34 or 36 ATPs if there's oxygen. But even if there's not oxygen, we can still get 2 ATPs. Glycolysis is a very ancient pathway, all right? So get 2 ATPs from 1 molecule of glucose. That's all it is. That's all you have to know about this, all right? Gluco Neo Genesis. Look at that term. Gluco, glucose, neo, new, genesis, make. So what does it mean? It means we make new glucose. What's big and red in these rocks? A big red rock eater. What does Gluco Neo Genesis mean? Make new glucose. How much do earrings cost for a pirate? A buccaneer. All right, so gluconeogenesis, we're going to make new glucose. From what? If you say starch, I'll kill you, all right? Starch is already glucose, all right? We're going to make new glucose from what? We're going to make glucose from things that aren't glucose, that aren't carbs. So we're going to make new glucose, make glucose from what? From things that aren't glucose, therefore from proteins and fats, lipids, all right? Make new glucose. Make it from things that aren't already glucose. How easy is that? Make glucose from protein fat. This is glucose that didn't exist before. We manufacture glucose inside of our body. We take fats and proteins. Remember that whole metabolism presentation that I did? Shows how we do all that, okay? So, but that's all it means. We're going to make glucose from proteins and fats. Okay? Easy peasy. Let's take a look here. Glycogenolysis and glycogenesis. So notice in both cases we're doing something with glycogen. We're either lysing it or we're genesising it. Notice this is glycogen genesis. The gens overlap. It's like glycogen and genesis, we overlap them, so we get to glycogenesis, okay? Glycogenolysis, so we're going to break down glycogen. Lysis, break down. Glycogen, break down. Break down glycogen. Well, what is glycogen? Glycogen is a storage molecule. Remember, that's how animals store glucose. It looks like a big tumbleweed. And what's it made out of? What's the tumbleweed made out of? It's made out of molecules of glucose. That's what glycogen is. So we're going to take glycogen Glycogenolysis, we're going to take glycogen and turn it into what? Turn it into glucose. Really not turn it into, just break it down. Break it down. Just break off a glycogen, big complex molecule made of bunches of glucose. We're just going to break off a glucose. Okay, that's all. How easy is that? Then Glycogen Genesis. Glycogen Genesis. We're going to do the exact opposite. We're going to take glucose and make it into glycogen. Look at these words. They're telling you what they mean. Glycogenolysis, break down glycogen into glucose. Glycogen Genesis, make glucose, take glucose, turn it into glycogen. All right? Or was Mickey Mouse when the lights went out? In the dark. These are easy. The words tell you what they mean. Okay? Last ones. Lipo, fat. Fat. Lipo. Lipolysis, break down fat. Lipogenesis, make fat. Well, lipolysis, break down fat. So remember the main dietary fat, the main storage fat. Triglycerides. What are triglycerides made of? Triglyceride. Glycerol plus 3 fatty acids. So what we're going to do is we're going to take a lipid, right, and we're going to break it down into glycerol plus fatty acids. How easy is that? Take a triglyceride, break it into its parts, glycerol and fatty acids. Okay? Lipogen, that's lipolysis. Lipogenesis means making fat. Making fat from what? Making fat from glycerol and fatty acids? No, that's too easy. No. We are going to have to, we're going to make fat from things that aren't fat. In the same way up here, Gluco Neo Genesis, we're making glucose from things that aren't glucose. Lipogenesis means making fat from things that aren't fat. Well, what things aren't fat? What are the two other main macromolecules in the diet? Proteins, carbs. So we're going to make fat from proteins and carbs. See how easy? Don't be upset by these terms. Don't be upset by them. There's no point in doing it. They're very easy terms. They tell you exactly what they mean. Now, in terms of metabolism, remember we've got two basic states, the fed state and the unfed state. Fed not like feds, not like G-men, not like Elliot Ness, all right? We're talking the fed state means right after you ate, okay? Right after you ate, that's the fed state. That's the absorptive state because you're going to try to absorb nutrients. The unfed state, the post-absorptive state, is when you don't have food available and you're having to raise blood glucose in some other way, all right? So what were the two hormones that control those states? Who controls the fed state? When you've got nutrients, who's going to help you get the nutrients into your cells and store them if need be, if you got too many? That would be insulin. So we have insulin. That's the hormone that governs the fed state. And then who do we have in the unfed or post-absorptive state? Well, now we've got the opposite problem. We haven't eaten anything. So our blood sugar is going to go. So we have to find a way to raise our blood glucose. And what hormone does that for us? That hormone is glucagon. Glucagon. Both secreted by the pancreas, all right? Insulin secreted by the beta cells, glucagon secreted by the alpha cells. Let's think about these terms here and how they're going to relate to insulin and glucagon. So insulin is going to promote some of these things. Insulin is going to cause some of these things to happen. So let's think about that. Insulin is trying to get sugar out of your blood into your cells. But if you don't have enough room in your cells, where do we go next? Remember, where's the next place we try to put glucose? If your cells are completely full, they're saying, no, we're full, we don't want any more. Where does glucose go next? We turn it into the storage form of glucose, which is glycogen. And so then we start filling up our glycogen reserves. So Remember, we got roughly 325 in the muscles, skeletal muscles, 125 in the liver. Once we fill up our glycogen reserves, what do we do with glucose next? We convert it to adipose and store it that way. Remember, adipose is a very efficient way to store. Glucose, only 4 kilocalories per gram. Fats, 9 kcals per gram. So what does insulin stimulate, therefore? Insulin is going to cause us, is insulin going to cause us to make new sugar? No, we already got sugar. We don't need sugar now. We just ate. We got plenty. Glycogenolysis, to break down glycogen to make more glucose? No, we don't need more glucose. We got extra glucose. We need to store it. So insulin is going to promote glycogenesis. It's going to cause us to store excess glucose as glycogen. And what else then? Remember, once we fill out the the glycogen reserves, where do we start storing glucose next? We start storing it as fat. So glucose is also going to promote lipogenesis. I mean, insulin is. Insulin is going to cause us to take all that extra glucose after the cells are full, start putting it into glycogen. After glycogen reserves are full, start putting it into fat. Okay? See how easy this is? Oh my gosh. I can't believe how easy this is. It's embarrassing. It's like I'm not even doing anything here. I shouldn't even be earning money for this. Well, I'm not. I'm making like $1.27 an hour. But, so glucagon. What's glucagon? Here, think back. What does it mean? What are we trying to do? Glucagon. We're trying to raise blood sugar. We need more blood sugar, all right? So, what is glucagon going to do to try to get us blood sugar? Remember, we ain't got food right now, all right? We're fasting, we're asleep, whatever. We ain't got food. So, glucagon needs to find some way to raise blood sugar. So what's it going to do? Well, let's see. How about if we make glucose from proteins and fats? Yeah, that's a good idea. So glucagon, let's see. I'm not running out of ways to do arrows here. So glucagon is going to therefore promote Gluco Neo Genesis because we need more glucose. What else is glucagon going to do to try to get more glucose into our blood? Well, how about if we take glycogen and break it down and make it into glucose? Damn straight, that sounds like a good idea. So we're also going to promote some Glycogenolysis, break down glycogen to get glucose. And then what else are we going to do? If we need more glucose, all right, so notice here, lipolysis, we break down lipids into glycerol and fatty acids. Remember the metabolism? Glycerol, we can turn that straight back into G3P, glyceraldehyde 3-phosphate, which we can turn into glucose. Fatty acids, we can turn into acetyl coenzyme A, make that into pyruvic acid, into G3P, make that into glucose. So you see, both of these can easily be converted to glucose. So if we're trying to raise blood glucose, what's glucagon going to do? It's also going to promote lipolysis, because lipolysis will give us the raw materials to make glucose, okay? So see how easy these are? They're not complicated. Just think it through. It's just a matter of looking at the word, seeing what the word means, and then figuring out when would you need to do those, okay? So don't get mixed up on these, kids. They're easy, all right? So, text me, email me if you're not sure. We'll figure it out, all right? Give me a shot. Give me a chance, okay? Think this over. Watch it a couple times. Get back to me, all right?